Alright, find an absolute extrema of f of x equals x cubed minus 3x squared minus 9x plus 1 on, first, in this closed interval negative 1 to 5, or on negative infinity to 7. I mean, it will help you if you knew that the graph of the cubic looks like this for coefficient of x cubed is positive, and it will be opposite like that if the coefficient of the highest order term is negative. But when you're only trying to figure out the absolute extrema, you don't really need the graph. You can just find the values at the critical numbers and also at the boundaries, and then just pick the highest value, lowest value of the function, and those are your absolute maximum and minimum. Okay. So let's try that solution. You first take the derivative, 3x squared minus 6x minus 9. Now, why are we differentiating? Because we want the critical numbers, right? So we set it equal to 0. This is a polynomial, so the derivative will always exist for a polynomial. You don't have to worry about the point where the derivative does not exist. Okay, so f prime of x set equal to 0 gives you the following equation. Which factors as x minus 3 times x plus 1 times 3, and therefore the solutions are when this is equal to 0 you get 3, when this is equal to 0 you get negative 1. So those are your critical numbers. Critical numbers. Okay. And we're doing, to do A, you have to evaluate at those critical numbers and also at negative 1.5. So let's try that. F of 3 is 3 cubed is 27 minus 3 times 3 squared is also 27 minus 9 times 3 is negative 27 plus 1. That gives you negative 26. F evaluated at negative 1, because that's the other critical number. That's negative 1 cubed is negative 1 minus 3, negative 1 squared is negative 1 minus negative 3 is negative 4, minus 9 times negative 1, that's plus 9 is 5, plus 1, that's equal to 6. Now, negative 1 happens to be also the boundary value, so in that case we've already done the left side. So the only thing that remains for us is to do f of 5, which again gives you 6 if you compute it. So now you have the lowest value, negative 26, 6 are the highest. So what's the answer? The absolute max is what? Negative 1,6 and 5,6. You have two absolute maximums. Okay. How about the absolute min? 3, comma, negative 26. Yes? Hmm?
That's a 5.
That's a 5. Yeah, 5.
Yeah, doesn't it give you 5?
F of 5 gave you 5? Okay, let me see. 125 minus 75, that's 50. That's equal to 6. I'm pretty sure it's 6. Everyone else agrees it's 6. Okay. Alright, so just check your calculation, it's 6. Now let's try B. Okay. Now, in part B, we have negative infinity. Alright, so if you try to evaluate the function at negative infinity, what would that mean? Well, think about this. If you have negative 1,000, let's just think about, instead of trying negative infinity, let's try something that's very big. Okay. So if you plugged in 1,000, 1,000 cubed, 1,000 squared times 3, 1,000 times 9, which one will be the highest? Which one will produce the biggest number? 1,000 cubed, 1,000 squared, 1,000 times 9? 1,000 cubed, right? 1,000 cubed will give you a million, a billion, right? This isn't a millions, this would be 3 million, that's 9,000. So, I mean, these two can't compare with what this is, okay? And the difference will be much bigger if you plug in x like a million, right? So, when it comes to plugging in negative infinity or positive infinity to a polynomial, you only need to consider what happens to the highest order term. So let's think about this. What is negative infinity to the cube? Now, first, is this plus or minus?
Minus.
Minus, okay. And is it a minus of a small number or a huge number?
Huge number.
Okay. So what will you get? Negative infinity. Right? So you can say that f of negative infinity is negative infinity. Now, in pre-calculus, you learned of this as something called an end behavior. You learned that when x cubed is positive, the end behavior of a cubic polynomial to the left side goes down that way, and the right side will be going that way. That's the end behavior. So if you also remember that, then without having to do this way of reasoning, you can just say, hey, this is a cubed with the positive coefficient, the end behavior going left is negative infinity. Okay? So that's negative infinity. And remember, this is not part of the graph, so even though, I mean, negative infinity will be smaller than any other number, right? So even though you know that you have the minimum without even knowing the other ones, this just means that this function will not have a absolute minimum or global minimum on this interval. Okay? All right. Now, what about the other endpoints? F of 7, right? F of 7 will give you 343, 49, 296. This one I have to do it. 296 minus 63, 233, and 234. Okay. I'm just doing this in my head because I know given time you can do this on your own, right? So you have some huge number. Okay. Okay. So what's our conclusion? What's the absolute minimum? No absolute minimum. What about absolute maximum? Absolute maximum is 7,234, because if you look at the boundaries, it's these two values. And what are the values at the critical numbers? These are the critical number values, right? These were the two critical numbers. And if you look at negative 26 and if you look at 6, you see that the absolute maximum is this one, because 234 is bigger than this value, both of these values. 234 is highest of these four values, and negative infinity is the lowest of these four values, and therefore
234.
It's 134? Thank you. How come? Oh, it's 196. Oh, all right. I see. Okay. 134.